Hello, Goody. Think of a delivery at its most abstract level. This is a map that represents any city. In any city, you're going to have a courier and a position that it has to go to a restaurant in a different position. Then, from the restaurant, it has to go to the client at a different position, and then it has to do a waiting time. We assume this time is positive and is different to zero. Then we have a courier going to a new order. This is the general idea of how we think of a delivery. And I think this applies to most levels and most case scenarios. We put everything in this line, being A, B, and C. These points are crucial because if we get to optimize every single one of these levels, we're going to be able to have a better delivery in an abstract level, just as we're going. Now let's figure out reality. Today we have people like DoorDash doing deliveries with bicycles and human power. This is what you see, and that's industry standard. Now this is Kiwi. This is us. We have robots, and we have people doing the robots. We have for 3 miles a person with 2 robots, an electric bike, and an electric trike that might be autonomous since we already developed this technology. And I want to show you exactly how this works and why are we better. So let's run both scenarios, and this is how it goes. When you have Kiwi and DoorDash doing deliveries and it's like ideal level at the same time, you're going to have the first point, that is the distance that covers the courier to the restaurant. This is simple. If you have an electric bike starting on a single point, you're going to be able to make it to the restaurant quicker. So this creates Kiwi doing lower time for a constant distance. This is how we win in the A point. Now let's go to B, the restaurant to the customer. Here we made a huge breakthrough as we made a line 400 meters before the client's position. Of course, bikes, electric, are quicker than regular, but in the last 400 meters, we'll drop a robot that is going to cover the distance. Now this distance is slower for Kiwi, and then times are also improved because electric bikes are quicker. This is the big part, and it's the waiting time for the customer, which is a big pain point. Now Kiwi is going to make the same waiting as DoorDash does for this hypothetical client, only that the waiting is done solely by a robot. This robot can later go to the sidewalk and be waiting to be picked up. The times are the same, but a Kiwi's courier is already doing a new order. This is efficient. Now, you might ask, what happens with the tricycle? Well, the tricycle we have can also do deliveries, and the idea is that it works as a regular bicycle. Only that when it's needed, and in the case like things go real quick, the trike might go and pick a robot in the last endpoint, which is actually the sidewalk, next to the client's house. It might pick a robot and then go to the next order, and pick the new robot. If it's needed, it can go and put in the third robot in the last 400 meters of a third order, so the person on the bicycle can continue work, while the tricycle can also do the same. This is why we win. So we have an improved time in every single level of the delivery, and we optimize the distances as we make them shorter and people do more work. This is why we have an ahead of 13 minutes against DoorDash. 2 orders per robot per hour creates positive unit economics and a cost of delivery of $5.55. Thanks for watching, Goody, and this is our main idea, to show you why we're different, why our idea makes sense, and why scaling up with us will make a huge breakthrough in the delivery market. Please let me know what would you like to see next. I'll be more than happy to show you. Thank you very much, and I hope to see you soon.